And welcome back, AP Econ students. Today we are looking at the FRQs from the year 2016 in microeconomics. So let's dive in and see what the focus is for this question. Now, this is number 1, which you can pretty much anticipate it's going to be something about a market type. So are they telling you perfect competition, imperfect competition, and what are the little twists and turns they're going to give you? So let's just see what they say. So the question starts out with, the market for bananas, muffins, and coffee are interrelated, and each market is perfectly competitive. Well, there was the clue we were looking for right away, perfectly competitive, and each one of them is. Okay, so just a quick review. If it's perfectly competitive, and you really want to focus on the fact that it says the market. So remember, when you're doing perfectly competitive questions, you're always thinking side by side, and the market is what spits out Mr. Darp. So are they asking you about the firm? Because the firm is where we would analyze Mr. Darp, and are we making a profit? Are we in long-run equilibrium? All of those things. Or are we in the market? Because they're two different concepts that are going to work for both. Obviously they're connected, but which are they focusing on? Well, this question says to focus on the market. Very easy mistake to make from the get-go is to think of this graph instead of the market graph. So it says we're dealing with the markets for the three. Bananas, muffins, and coffee makes sense. You think of coffee and having muffins with coffee, and maybe the bananas are in the muffins. They're interrelated, which makes sense. So question A starts out with, in the market for bananas, the equilibrium price is $1 per pound. So I think just to start off, I'm going to use this as my work area over here, and I'm going to start with A, and I think we'll put our conclusions over here, but we're going to show some work over here. So let's just go ahead and start with the market for bananas, and I'm going to draw that here. And so if it's the marketplace for bananas in perfect competition, I could just go ahead and draw these being unit elastic, and this is just my work, so it's not going to be super important how detailed I get. I just want to I don't want it to be confusing to anybody, but I'm not going to be as detailed as I would if it was actually required for the question. So it says, in the market for bananas, the equilibrium price is $1. Okay. $1. And the equilibrium quantity is 1,000 pounds per week. Okay. Now, this is not required to draw by any means, but it's going to help you understand and analyze the question, so be ready to make some sketches if you need to. So it says, suppose the government imposes a price floor on bananas at $1.20. Well, that's going to be up here. Okay, and so there's our price floor, and you should right away be thinking the following. Well, this price floor is making a difference because the floor looks like a ceiling. It's higher than equilibrium. This is actually relevant. Causing the quantity supplied to increase to 1,500. So here's our new quantity supplied, so I'm going to dot down there, and I'll just drop down here. And we have now that's at 1,500, and that's the given information. So this is what we're dealing with right here. Okay, that situation, and now we'll go into the question. So A is the situation. So let's see what they ask us for 1. A1 says, would the price floor result in a shortage, surplus, or neither? Well, you guys should know price floors are always going to result in a surplus, and the reason is the quantity supplied at this price is higher than the quantity demanded. Pretty simple. So we're just going to say surplus because the quantity supplied is greater than the quantity demanded at $1.20. Simple. Get your points. Number 2. Regarding the bananas. Calculate the price elasticity of supply if the price increases from $1 to $1.20. So this is good review again, calculating elasticity. I'll do the work over here, and you just want to remember whether it's elasticity of supply or demand, it doesn't matter. Your elasticity calculation is always going to be the percentage change in quantity over the percentage change in price, and price goes on the bottom, and we do this absolute value, okay, because we do the midpoint method. There's more than one method, and in fact, on this particular test, if you were to look at the guided solutions, I think you'll see 6 different answers, if you can believe that or not. 6 different answers to the elasticity because there's multiple ways to be taught to calculate it. We do the midpoint method, and so we'll just focus on that. So don't get distracted by those other answers if you're looking at that. So we know we're going to have a fraction above, fraction below. Okay, so let's just focus on the quantity. They said we went from 1,000 to 1,500, so the difference is my numerator. The difference between my two quantities is 500. The average of my two quantities is 1,250, so there's my numerator. In my denominator, the difference of my price, it went from $1 to $1.20, is just 20 cents, so I'm going to say 0.20. And the average of $1 and $1.20 would be $1.10. Okay? And so then from here, you guys do have a calculator on this exam. If you were concerned about it, you can knock this out, but it's not going to be required. So if we just clean this up a little bit, I'm going to knock off the zeros right here in this numerator. And then I'm going to see 50 goes into both of those, 25 goes into both of those, twice in the top, 2 on the bottom. So I would get 2/5 in the numerator. And then in the denominator, I'm going to knock off those zeros, move my decimal over, and I get 2 over 11. Okay, and then I would flip that up, and what I wind up getting, my 2's cancel, and I wind up getting 11 over 5. And if you wanted to do the decimal, 2 1/5, you would get 2.2. Okay, so there's all the work, and it says show your work right here. So all of this, if you guys can, I'll move this over to here for number 2, and I'm going to say, I'm just going to summarize a little bit. I'm going to say I had 500 over 1250, and that was over 0.2 over 1.1, and that equaled 2/5 over, move this up a little bit, 2/5 over 2/11, and that was equal to 11/5, which was equal to 2.2. Okay, so there is my elasticity, and there's my work shown. Okay, I'll leave this here for now. We'll wind up erasing this eventually. All right, and then part 3 says between $1 and $1.20 is the supply elastic, unit elastic, or inelastic? Well, there's a couple ways to do this. The easiest way is that we just calculated the elasticity coefficient going from or in that zone being 2.2. So you guys could just, if you have it memorized, if you remember, the rule is your unit elastic, you equal 1. You are relatively elastic if you are greater than 1, and you are relatively inelastic if you are less than 1. Move that one over and make that look a little better. Okay, so unit elastic, your elasticity coefficient is equal to 1. But if you're greater than 1, you're elastic, and it's inelastic if it's less than 1. All right, so the fact that this is greater than 2, you could just make a statement that say price elasticity of supply is greater than 1, therefore supply is elastic. Okay, so I would say elastic because 2.2 is greater than 1. And that just shows you know the rule and you're fine. Okay, and if you want to be, you could say supply is elastic. It's obviously it's directly related to the question, so don't get too hung up on the grammar there. Okay, let's move on to part B. So part B says, draw a correctly labeled graph of the market for muffins. Indicate the equilibrium price and quantity labeled P sub 0 and Q sub 0. Okay, well now we actually have to use a graph. All of this over here is erasable, and I think we have enough room. We can make a decent little graph right here for part B. Okay, and so it's just going to be the market. All right, so whenever you get asked to do those, I recommend using a straight edge. Use your ID or credit card is usually good, or a ruler. And the market, so this is going to be just the marketplace, so we'll label this supply and demand. We've got our quantity, and we have price or cost. You can put a dollar symbol, either one's fine. And it says label this correctly, and so we have Q sub O. So there's our quantity, and here is our price, sub 0. Okay, and this is the market for muffins. and it says, yeah, so if you wanted here, sneaking this in up top here, I'm going to say the muffin market. Okay, so there it is. That's part 1. Then, let's see if we have to do anything to the graph. It says, on the graph drawn in part 1, show the impact of an increase in the price of bananas on the muffin market. Okay, so it says here bananas are an input for muffins. Makes sense. Banana muffins need bananas. Well, bananas are an input or a resource, and this goes back to shifting supply and demand. If you remember the shifters of demand, we could review both of these. We had our demand shifters, and we had our supply shifters. And this was 3 naked penguins in France, if you remember. And this one, did we have penguins never talk to giraffes or elephants? We had our 6 things there. Well, for demand, if you guys remember, we had taste and preferences, number of sellers, price of related goods, and inputs, and we had future expectations. Well, we have an input here, so that's not related to there. Now let's come over here. For supply, we have price of resources. Banana is a resource, so this could be a supply shifter. Number of sellers, technology, government action, surplus and taxes, opportunity cost of alternate production, and then we have expectations of future profits. So of our 11 things here, price of resources or inputs, there it is. So it's a supply shifter, and its price went up, which tells me we're going to have a decrease in supply here. Okay, so we have a decrease, and so it says here, draw on the graph the impact of an increase in the banana prices. Well, we're going to show this, and I'm going to go ahead and get rid of that for right here. And there's S prime, and you just want to make sure you show your arrows. Marker's getting a little dead here. And we have S prime, and it is wanting our new equilibrium to be P sub 1 and Q sub 1. Okay, so now we've got this new spot down here. I'll go down there and I'll make that Q sub 1. And our little spot over here is P sub 1. Okay? And I when in doubt, make those nice and big so they're easy to read. Okay, we've got 2 done. All right, on the same graph, completely shade in the area that represents the change in consumer surplus. So I'm just going to draw a little note here just to review. Remember, when you have consumer surplus, that's going to be when you divide this into producer surplus and consumer surplus. So that's going to be this lower triangle right here. Okay? So you think to yourself, I'm going to just draw that again. So what happens to that lower triangle when we have a shift like this? And now here's my new equilibrium. Okay? What was the change? Well, this question actually, this is a few years old. This can be a little bit confusing because you could overthink it and erase some that you shouldn't. I'm just going to tell you, here's what they're looking for. What they're looking for is, here's where it was originally, down here, was this lower triangle, and now it's going to be this triangle. So what they're trying to show you is that you gained this much, but you lost this much. And that's the change. Now, what a lot of students would say is, well, yeah, but didn't you lose a bunch of stuff down here too? Yes. And so I doubt you're going to see this kind of question because it was, when you can argue outcomes, it's not a very good question. But what they're basically looking for is, here was your gain right here. Okay? And then this is what you lost from before. So it's this little, it's this trapezoid here. That's what they were looking for. Okay? And that is part 3, that's 1, 2, and 3. Okay? 1, 2, and 3. All right? Now, time for part C. Okay? I'm going to erase a little work up, erase some of our prior work here, and now we have part C. Obviously, easily could have fit the full graph up here, but we didn't do that. All right, so here's C. So C says, in the market for coffee, the equilibrium price is $3 a cup, and the equilibrium quantity is $100 a cup. So I'm going to draw that. I don't know if I'll need this, but I'm just going to make a sketch, and if I have to make a nicer one, I will. But so this is just coffee, and I like to do this when I'm doing these questions because it just gives me a feel for what's going on. And they say, okay, the equilibrium price, what they say is $3 at 100, and you have 100 cups, and that's the market, not the firm. And you say, okay, and then they give us the cross price elasticity CPE is equal to -2. All right, so you want to remember cross-price elasticity tells you about the relationship between two goods. And you want to make sure that you have all of your elasticities down as far as elasticity for demand, elasticity for supply. But then you had the three lesser known elasticity values. So the lesser known elasticities are cross-price elasticity and income elasticity. And so if you recall, income elasticity is going to tell you about whether a product is positive or inferior. And as your income increases, you buy more of something. If you buy less of something, it's inferior. If you buy more of it, it's positive. And cross-price elasticity tells you about the relationship between goods being a complement versus a substitute. So if you recall earlier in the year, we had a PowerPoint that was contrasting mountain bikes with mountain bike helmets. And obviously they were complements, and so we were calculating cross-price elasticity. So what this is telling us here is that the cross-price elasticity between coffee and muffins is negative. Now, if you recall, when your cross-price elasticity is negative, that means your goods are going to be complements. So I'm just going to jot that down real quick here. Quick swap out here of my marker. When your cross-price elasticity is negative, your conclusion is going to be that the items are complements. And if your cross-price elasticity is greater than 0 or a positive number, it means you have substitutes. So this makes sense. We have coffee and muffins. Those are complements. They go together. It's a negative number. It makes sense. All right. So question number 1 here, kind of going over what we just said, it says, are the coffee and muffins normal, inferior, complementary, substitute? So notice they're trying to trick you here by even throwing in the normal and inferior issue, and you go, well, no, that would be income elasticity. This is cross-price elasticity. It's negative, and all you need to say is that they are complements. And no explanation required. So there it is. The next question says, assume the supply of coffee is perfectly elastic. All right, so perfectly elastic means horizontal. Using the equilibrium price and quantity given, draw a correctly labeled graph for the coffee market. Okay, so what I had drawn up here, what's kind of interesting, is this is not what they're saying it actually looks like, because they're saying our supply curve is perfectly elastic. So we're going to have to draw that. So like a nice neat graph. And the demand curve is fine, but they're telling me the supply is perfectly elastic. So there's my supply curve. Okay, so then here's still my quantity, and here is my price axis here. Now it says based on the information above. So I drew this just thinking through it actually incorrectly because based on what they were saying, I was assuming we had unit elastic, but we hadn't gotten that far in the question. So this down here is 100, and then this right here is going to be at $3. Okay. So assume the supply of coffee is perfectly elastic using equilibrium price and quantity given above. Draw a correctly labeled graph for the coffee market and show an increase in the price of muffins. Increase in the price of muffins on the coffee market. Okay, so what happens when there's an increase in the price of muffins, and that's a complement? So let's think through that. So this goes back again, I had this written earlier about our shifters. Well, if these two items are complements, what happens when, and I'll just go ahead and write this again. If you guys remember, I had written on here, I had 3 naked penguins in France. And this right here was the price of related goods. And those two relationships for demand, these were demand shifters, by the way, are substitutes and complements. And so this will be a good little review. If you remember, if you have something that's a complement, and I always like to think of milk and cookies, Oreos and milk. If you go into the store and the Oreos are on sale, you'll be like, oh my gosh, I'm going to grab some Oreos. But it also would make you think, since the Oreos are on sale, I'm going to wind up buying milk because they're complements. But the opposite could happen too. If you go in and all of a sudden the Oreos are triple the price, you're not going to get the milk. So the price of a complement, as its price increases, you wind up buying less of the other complement. So let's think through this. What it says is, show the impact of an increase in the price of muffins. Well, if muffins got expensive, and you always have muffins and coffee together, the demand for coffee is going to go down. So what they're wanting you to do is show a decrease in the demand for coffee. Okay, so if you think through that, it should make sense. But it's a little bit of a puzzle here, and that's how they make these. So we had a decrease in demand, I'll call that D prime. The decrease in demand, oh, and by the way, this is the coffee market right here. Okay, so the increase in the price of a muffin led to a decrease in the demand for coffee. So people are buying less muffins and less coffee. So then let's see the last part of the question. So I think we have this right, okay? And then it says, given the original quantity of 100 cups of coffee, which I have right here, per week, if the increase in the price of muffins is 10%, calculate the new equilibrium quantity. Okay, so we actually have to go back, and now we have to use this little guy right here. Okay, so I'm going to do a little work off to the side right here. And so we don't get any confusion here. Let me move that up. So what I'm going to do, I'm just going to write our cross-price elasticity formula here. Write that up here. So if you recall, the cross-price elasticity is going to equal the percentage change over percentage change. Okay, and remember, price goes on the bottom, so we have price and quantity. But the difference here, it's two different goods, so it's the quantity of one good over the price of the other. Now they tell us here if the increase in the price of muffins is 10%. Well, then this must be the muffins. So this is the price, and I'm going to put an M for muffins, and this is going to be the quantity of coffee. So based on the information we're given, we have price information about the muffins and quantity information about the coffee. So that's why I'm using the coffee in the numerator and the muffins in the denominator. So here's my equation, and they told us that this is equal to -2. Okay, so -2 is equal to, and they just told us here that the percentage change in the price of muffins is 10%. So this is 10%, and this up here is X. This is going to be X%. That's what I'm solving for, because it says calculate your new equilibrium quantity. So how much did this change over here? So whenever I solve percents here mathematically, I like to always convert to decimal. It doesn't really matter on this one. So I'm just going to make this X over 0.1. Same thing, but you wind up cross multiplying here, and you get -0.2 is equal to X. Or you get -20% is equal to X as a percent. So this means 20% decrease in the quantity of cups, or the quantity of coffee cups of coffee sold. So we went down 20%. Well, what's 20% of 100? 20. We had a decrease. That means this number right here dropped to 80. So the first thing we had to do was we had to take the cross-price elasticity that was given to us, and we had it set it equal to the equation, then subbed in what we knew. 10% was given. We had that value. We solved for the percentage of the drop, and then we adjusted it to what we were given originally. And they always give you friendly numbers like that. So we have our work shown here, and we could say 20% of 100 is equal to 20. So the number of cups decreased to 80. Okay, and just when in doubt, if you want to write a little bit more, you can. Okay, so that was 2016 question number 1, and so you could see they kind of focused on, it's kind of interesting, they focused on the market types, they focused on perfect competition, but then of that they focused on the market side, not the firm, and then wove in a bunch of all sorts of other aspects. So that was a little different, but a good question covering all sorts of topics. All right, so that is number 1. Let's move on to number 2. All right, question number 2 here on 2016. So immediately you notice you have a big table here, and you've got two quantities and total benefits. Well, before going any further, whenever you get a table that's got a total benefit listed, you're going to have to find a marginal benefit. And sometimes they give you a marginal and you need to calculate total. So we're going to have to do just some simple, probably some subtraction here and insert a couple more columns. So actually what I did over here was I separated this because we're going to actually want to do some extra work over here. All right, so this says Martha has a fixed budget of $20 and she spends it all on two goods, X and Y. And again, as you'll see, you guys, the AP contests are so not creative. They do stuff like X and Y all the time. The price of X is $4 per unit, and the price of Y is $2 per unit. The table below shows the total benefit measured in dollars Martha receives from the consumption of each good. Now, if you recall, early in micro, we talked about marginal benefit, or when we often talk about diminishing marginal returns. The more you consume of something, the less beneficial it is. And that's a little bit tied into here. But there was also the problem that had to do with when you have two goods and you're trying to equate how much of each good to buy. How do you maximize your benefit or maximize your budget? And that's what this kind of problem is. And we had, if I remember back on the PowerPoint, we were comparing go-kart rides to amusement park rides, something like that, and how many of each should it be. And so you want to be able to recognize that when you see this question. You go, oh, okay, I'm going to have to do my marginal benefit, but then also my marginal benefit per dollar. And so once we do that, we're going to figure out the best combination of goods to consume. And if we do that, we'll probably address every one of these questions, more than likely. So before going further, since we have a quantity of over here, this is how much of quantity, or how much of product X, and here's the benefit from them. So what I'm going to do is just insert another column here, and I'm going to say, well, I'm going to figure out what my marginal benefit is. So I'm just going to do marginal benefit, and I'll extend this over. And we'll do that. And so the marginal benefit here for the first one was 16. So we're just subtracting here. And then 28 minus 16 is going to be 12. And then here it's going to be 8. And then 4. And then we're down to 1 for our last one. So there was the marginal benefit. And you could see that it was decreasing. And before we go over to the other side, I'm going to go ahead and do not just the marginal benefit, but I'm going to do the marginal benefit per dollar. And that's going to be my other column I want to put in here. So I'm just going to say MB, and I'm just going to put per dollar sign. Now, to calculate marginal benefit per dollar, you're going to need to know how much this good cost. So over here, given, it says the price of product X is $4. So what we're going to do is take these and divide them by 4. Now what you're going to notice is you always get pretty friendly numbers to deal with here. So we're going to divide by 4, and 16 over 4 is 4. Here we get 3, 2, 1, and a quarter here. Okay, so there's our margin utilities per dollar. Well, now we're going to do the same thing for product Y. And so extend these over here. And let's figure out what our marginal benefit is. And then we'll do marginal benefit per dollar. So just subtracting here, 10 minus 0 is 10, 18 minus 10 is 8, 24 minus 18 is 6, and then we have 4, and then we have 2. All right, and now we're going to calculate our marginal benefit per dollar. Now product Y, according to the problem, is only $2. So we're going to divide each one of these by $2. All right. And so 10 divided by 2 is 5, 8 divided by 2 is 4, 6 divided by 2 is 3, 4 divided by 2 is 2, 2 divided by 2 is 1. So there's our marginal benefits or marginal utilities per dollar. You can say it either way. All right, so now if you recall, the strategy was equating these two columns. This was the secret to doing these questions. So where on those, where are those two things the same? So what I'm going to do is actually, I think we have 4 times where that is true, and we're going to highlight those. So in blue here, it looks like they are both 4. Okay. And then in green here, we have they're both 3. I'll do a rectangle around there. They are both 3. And then in red, looks like they're both 2. We can do that in a triangle. And then they are also both 1. And we'll go back to a circle there in orange. Okay, and so we're going to have to compare those and see what we get. So I'm going to go back to blue, and let's see that combination. So when their marginal utilities per dollar are equal, that would mean we would have just 1 of product X, but we would get 2 of product Y. So I'm going to write that equation up here. I'm going to say, well, it looks like, I'll put it, let's see. Marker showing up a little better here. So what I'm going to say is we could have gone with 1x plus, and we would have gotten 2y. And we'll figure out what that would equal. And that's because the quantity of the consumption based on when they were the same. Okay, then going to green, when they're both 3, I would have had 2 of product X, and I would have had 3 of product Y. Figure out what that equals. And then our next one here looks like it would be 3 of product X plus 4 of product Y. We'll figure out that total, and then the very last one was 4 of product X plus 5 of product Y. Now what we're going to do is we're going to calculate what it would cost to do that, and if you recall in the very first sentence of the problem it said she had a budget of $20. Okay, and so we'll go ahead and do these in black here. So if good X was $4, so if you recall, very important on this side, just remember, good X is $4, okay, and good Y over here was $2. Okay, so we have 1 times 4 plus 2 times 2. This would give us $8. Okay, 2 times 4 is 8, plus 3 times 2 is 6. I believe that would give us $14. Okay, 3 times 4 is 12. 2 times 4 is 8. 12 and 8 is equal to $20. Then the last one, 4 times 4 is 16. 2 times 5 is 10. 16 plus 10, that would be $26. So those were the options, and since the budget was $20, that's the combination of goods that would maximize her budget. Okay? So from the top, when you get a budget question and you have 2 goods, you have to figure out the marginal utility per dollar, or marginal benefit per dollar. And so if you get total benefit, you have 2 things you got to do. First, calculate the marginal benefit from the total, and then divide it by the cost to get the marginal utility per dollar. You'll have several candidates, see which one fits the budget. Okay? Now with our work right here, we can probably answer all the questions, more than likely. So let's see. Might have to make a couple adjustments, but we'll see. All right, so the first one says, what is Martha's marginal benefit from the 5th unit of good X? Well, this one it's just whether or not you can read this. So her marginal benefit from good X is on this column here, and we calculated the marginal benefit. It was only 1 because it went from 40 to 41. So the answer to A, her marginal benefit there would just be $1. Okay. Then question B, calculate the total consumer surplus if Martha consumes 5 units of good X, and show your work. Okay, well this is kind of an odd question, and so I want to show you how this works. I'm going to just draw you a little work here. So when it says consumer surplus, or total surplus, calculate the total consumer surplus, it says. What you're probably thinking of is back to this graph when you would have supply and demand, and you would say they're wanting this area right here. Is that what they're looking for? The total consumer surplus, that triangle? And you might be thinking, well, how do I put that on a graph? And you're in the ballpark, but here's how it works. If you recall, when we have total surplus is the consumer surplus plus the producer surplus. It's both things. And so when you get a list here with the total benefit does not account for the cost of actually doing this. So the total benefit, or the total surplus, if you want to say, is 41, because these are accumulating here. So of consuming all 5 units, she had a total benefit of 41. However, she had to pay for it as well. It cost her. And in fact, it's $5 per unit. So this is a little bit of an odd kind of a can feel like an out of the blue question, and it is a little bit peculiar, and it's the benefit of kind of going over an old AP test. You go, oh, that was that little weird question, and then you know how to handle it. So basically, it's this easy. You just say, oh, well, the total benefit is 41, and then I had to subtract from it the cost. And the cost was 5 units times the $4 they cost, which is 20. So 41 minus 20 is equal to $21. That is the total consumer surplus. So just remember, total benefit includes the costs, and whatever you have to pay, that's going to be the producer surplus. Okay? All right, there's part C now. Part C says, Martha's is currently consuming 4 units of X and 2 units of Y. Use marginal analysis to explain why this combination is not optimal. Well, if you look at this, and then we'll just look at our work we did before. Her combination, she's using 4 and 2. Well, if you're going to consume 4 units of X, you're going to want to consume 5 units of Y. Or if you only consume 2 units of X, you would only consume 1 unit of Y. So the easiest way to explain, using marginal analysis, why this is not a good combination is because at this combination, the marginal utilities per dollar are not equal. And that's what I would say there. So why is this combination not optimal? I would say at 4 units of X and 2 units of Y, marginal utility per dollar is not equal. Okay? And again, whoever's grading this has an economic background and they understand there's not a further explanation. The fact that you say those aren't equal implies you know the context of the question, especially if you have this work supporting it here. Okay? All right, let's look at D. So D says, what is Martha's optimal combination of goods X and Y? Well, we just did it right here. And actually, what's strange is it doesn't say to show your work or justify your answer. So we'll just copy this from over here. It's going to be 3 units of X, 4 units of Y. Okay. Then part E, we'll erase this and we'll move over here. So part E says, indicate whether each of the following will cause the optimal quantity of Y to increase, decrease, or stay the same. Okay, so let's see what they say. For part 1 of the question, it says, what happens if the price of good Y doubles? What will happen to the optimal quantity? Well, let's go over here and see what would have happened. If we would have had to divide by 4 instead of dividing by 2, look what would have happened to our marginal benefits per dollar. If I would have had to divide everything by 4, this would have went to 2.5, 2, 1.5, 1.5. All of these would have decreased. So because these would have decreased, my optimal combinations would have went down because my marginal utility per dollar would have went down. So if the price of good Y doubles, then the optimal quantity would decrease. Okay, and then the next one says, what would happen, what if Martha's income falls to $10 with no changes in price? Well, she only has $10, so you guys can see that her optimal quantity of Y, she would be down here, she would only be able to get 2 and still fit within her budget. So it would have decreased again. So this is why, one of the reasons why I want you to take the time to go ahead and do this, because it's going to enable you to easily answer the others without having to guess. Okay. And then for number 3, what if Martha's income doubles, so her income goes up to 40, and the price of both goods double? Well, if the price of both of these goods doubled, and these went up to 8 and these went up to 4, so the price of everything doubles, it's going to cut all of these in half, the amount of consumption in half. But if her income doubles as well, she would be able to afford the increase of Y. So if everything doubles, including price and income, it all cancels each other out. So you would have no change. Okay. Now, if you're not totally convinced and you have time, what you can do is just go ahead and double this to 8, double this to 4, go ahead and run this again, and see what happens with her budget now being 40, if this is not intuitive to you. And you could prove to yourself, and you go, oh yeah, my equations are different, but in order to get the same quantity, what's going to happen is it's going to require $40 to get that, but she's going to have $40. So even if you want to look at just this one, where we had 3, this would probably be an easy one to look at here. For this one right here, if we were dividing by 8, this would have been a 1. So we would have had 1x, that would have been $4. And then this one, we would have had, it would have been 1, but it would have equated with this 1 over here. So this combination would have stayed the same, but we still would have had 3x plus 4y, but this would have been 3 times 8 is 24. 24 plus 16 would have been $40, but then her income doubled to 40. So that's why there's no change. All right, so there is question number 2. And so now we just have number 3 left, and we are done. All right, now question number 3. This question says, Camden's Cakery is one of many dessert cafes serving a local community. Each cafe produces a slightly differentiated product. There are no barriers to entry or exit. The firm is in long-run equilibrium. All right, so it's imperfect competition. Imperfect. And it's slightly differentiated, so it looks like a monopolistic competition. And here's, so you want to be thinking of that. And then it says, draw a correctly labeled graph showing Camden's demand curve, marginal revenue, blah, blah, blah. So let's draw imperfect competition in long-run equilibrium. Well, this is going to be good. Before I do that, I think I actually want to draw 3 graphs. This will be a good review just to make things quick, to quickly do this. And if you recall, whenever you want to draw these, so I'm going to draw 3 up here, because I'm actually going to draw one making a profit, one breaking even, and then I'm going to also draw one that is losing money. Okay? So, and this is just imperfect competition. So I'm going to start with, I'm going to start up high. And I'm going to say, all right, let's chopstick it. So if you guys remember, we do that. And then I'm going to pick a point in the middle of the chopsticks to be the minimum of my ATC. And so I'm going to bring my ATC in here to hit that and come up. So there is my ATC. Remember, demand and marginal revenue, this is demand and price, and marginal revenue separate. And then I would bring my marginal cost curve through here, catching the minimum. Okay, so there's my marginal cost curve. And then, here was the part that was the most complicated. We got all sorts of intersections going on. You want to make sure you review this really well. But our tattoo always works. So we want to contrast, where does MR equal MC? So where MR equals MC is going to be, well, here's my marginal cost curve, here's marginal revenue. There is that very important spot right there. Well, that's going to be the quantity. Again, it's always the quantity of profit maximization, where MR equals MC. But what's going to happen here is you're going to elevate to the price curve. So the price and the demand curve, the same thing. And if you look at that right there, that whole rectangle, that would be the amount of revenue that's brought in. Here's your quantity. There's the price you charge. There's your revenue. But then at that quantity, where it hits the cost curve, that would break it up into our 2 sections. So down here, this is going to be our cost, and up here would be our profit. So I'm just going to shade in the profit box right there. Okay, and the rest would be cost, but the whole thing would be revenue. Okay, and that would be a monopoly making a, sorry, I should say imperfect competition making a profit. Now, there is also one little thing I want to emphasize while we're looking at this graph, and you want to keep in mind the importance of where the marginal revenue is equal to 0, or where it intersects the quantity axis. That's a really important place. And if you recall, this is the spot that is going to divide your demand curve up into the elastic zone and the inelastic zone. And this location is actually where it's unit elastic. And so if you recall, we only produce in the elastic zone. And so just as a side note, when people say, Why don't monopolies keep raising their prices? Well, the reason is they're in the elastic zone, and if you're elastic, if you keep raising your prices, your total revenue goes down. In the elastic zone, you want to lower your price to maximize your revenue. And in fact, if you recall, this little spot right here, there was at the same time, there's a PowerPoint that shows the total revenue curve that is increasing. Total revenue maximizes when marginal revenue is 0, and then it decreases. And this is a PowerPoint. This is back in Unit 4 if you want to look at that. So this is the total revenue curve. Increases, then decreases, because this being in the elastic zone, this is the elastic side, and this is the inelastic side. That's just a little side note. What I want to do is keep continuing so we can contrast these three graphs. So there is imperfect competition making a profit. And again, here's the profit, here's the cost, and this entire thing, this would be our total revenue, the entire box. Okay, so now I'm going to go down just a little bit lower, try to draw this again. And this is going to be imperfect competition breaking even. Now, this is always a little tricky to sketch, and you do it in a different order. And because you haven't had a lot of board reps, make sure you're practicing these sketches. Well, what we do first is we actually draw our Nike Swoosh marginal cost curve on this one. And we say, well, there's our marginal cost curve. And MR equals MC, this is going to be the quantity of profit maximization. And that is going to wind up being the target. Because I'm breaking even, I have to have my costs equaling my revenue. And so I'm just going to have one box. I'm not going to have a profit box or a loss box. So in order for that to happen, if this is how much money I'm making, and I bring that over and I say, well, here is my revenue that I'm making, and that's got to be where my cost curve hits too. So what I'm going to do is I'm going to sneak in my ATC, and my ATC is going to hit right there, but it also has to keep decreasing. It has to keep decreasing because, remember, it hits the marginal cost curve at its minimum. And so you want to keep decreasing here, and it's tangent right there, and it decreases to there and then increases. And so you kind of have to force that ATC in there so that it winds up being a point of tangency right there. And it's tough to make the graph really nice because it's a little tricky to draw, but I think you get the idea here. Okay, and so on this one, we would be, our costs were equaling our revenue. We would be in long-run equilibrium. And that's what it would look like. And so you could say, oh, well, MR equals MC, there's my price, but then that's also my cost. Okay? And so I think if you contrast this one with this one, I want you just to look at the ATC. Notice how the ATC elevates in this picture to be here. Okay? Now for the next one, it's when you're losing money, you just keep moving that ATC upward, and you'll get the idea. And so if we say, here is our marginal revenue, here's our demand price curve, and on this one I'm just going to make my ATC way above here to make sure that I'm losing money. Okay, so ATC is high, and then I'm going to bring in my marginal cost curve, and if I exaggerate this, you can just see clearly that your price is below your cost, so we'll be losing money. Well, here's our MR equals MC spot, still very important, quantity of profit maximization, and we're going to elevate to here. Well, hitting the price right there and going left, well, there's going to be the revenue that's brought in. But unfortunately, if we keep elevating to the cost, it's costing us more than we're making, and this would be our loss right here. Okay, so this is my loss box. Up here, if you recall, this was the profit. So I just wanted to do this as a light review. The graph, the one that this Camden's Cakery is referring to, is actually this middle one, because it says they're in long-run equilibrium. And so here we are, okay? And it also says there's no barriers to entry, so if there's money being made, profit-seeking entrepreneurs can still enter this market. Not as easily as perfect competition, but they can still enter, okay? So just notice how the ATC was very low here, and it kept elevating for each one, but the rest of the graphs kind of look the same. Okay, so there's some good little review. So I'm going to leave this here and actually redraw, make it nice and neat here, pretending this is our test situation. So for part A, it says, draw a correctly labeled graph showing Camden's demand curve, marginal revenue curve, etc. So we're going to make sure we make this nice and neat. Okay, and we say, well, let's make a good demand curve and also my price curve. You don't have to put the P there, but I like to. And there is our marginal revenue curve. And again, having a straight edge is a great idea on here. But we're going to start with the marginal cost curve, because that's going to give us our targets. So MR equals MC. That's going to give me this really important spot right there. That's my point of tangency for the ATC, and that's also the top right here. This is where my costs come in. Okay. Actually make that just a little straighter. And then sometimes once you start editing your picture on a marker board, it just starts getting worse here. Okay. Now, what I'm going to do is slightly different than when I drew it here. Is actually what I like to do is I know that my ATC minimum's got to be lower than here, so I'm just going to go to about right there. And that's going to be my ATC minimum. My ATC is going to go up like that, but it's also going to go up on this other side, and I'm going to try to increase and just catch this point of tangency right here and increase right there. Okay. And, you know, if you're in the ballpark here, that's not bad. Okay, and so there's our price, here's our quantity. All right, and let's see what else they ask us to do. Draw a correctly labeled graph showing Camden's demand curve, got it. Marginal revenue curve, got it. Marginal cost curve, got it. Long run ATC, now that's a little bit unusual. They don't want it to just be the ATC, they want it to be the long run, so make sure you have that on there. Label Camden's profit maximizing quantity as Q sub M. So that was our MR equals MC. So it's going to be Q sub M. And the output as P sub M. So that's going to be right here on the price axis sub M. Okay, so that's what we're looking for. All right, I think we got it. Now it says B, on your graph in part A, label the output at which total revenue is maximized. Now be really careful here. What many students did, and this is on the feedback they get, is they read this too quickly and they said total profit. And they think total profit, well, this is the profit maximization, quantity of profit maximization, that's the same thing. It's not, because it said revenue. And in fact, if you recall, as we were reviewing the concepts over here, remember the total revenue is actually when marginal revenue is equal to 0. And that can be a little subtle thing here. You got to remember, it doesn't say profit maximizing. It says total revenue. Revenue is maximized when marginal revenue is 0. So that's actually this little guy right here. So I'm just going to drop that down, and I'm going to label this as my quantity sub R. Okay? Then, so there's A and B. Part C, do firms in this market experience economies of scale, diseconomies of scale, or neither in long-run equilibrium? Explain. Well, just a little bit of review on that one. If you remember, the long-run ATC, it would have all of these short-run curves, and the way we learned this was we have 3 phases, and we had all these short-run curves, and we'd say, well, you're in economies of scale if your costs are coming down as you make more stuff. As your output increases, your costs are coming down. Well, if that's true, that is economies of scale. Economies of scale. If, as you make more stuff, your costs stay the same, you're in constant returns to scale. So that was the constant returns to scale. And then as you make more stuff, if your costs are going up, you're in diseconomies of scale. Those were your 3 phases. And so all you have to do is what's happening to your costs, what's going on where you're making your product. Okay? And so if you remember these 3 phases, this is actually a very easy question. If you'll notice, what is our long-run average total cost curve doing at the quantity we're making it? It's decreasing, therefore we're in this phase. Okay? So for part C, guess I'll just sneak this in right here, and double check that, and we have to explain. Should have made this just a little lower to give us room. All right, so I guess I'll make that a little bit lower here. So for part C, what do we experience? And we can say we are in economies of scale. And our explanation is going to be economies of scale because the long-run average total cost curve, the LRTC curve, is decreasing. At the quantity of production. And if you wanted, you could say at Q sub m, that's where we're producing. So we're just saying at this location we're decreasing, we're in economies of scale. Okay, so there it is, part 3, nice little review of some imperfects. And oftentimes this could be the kind of question you would get in number 1, and it would be more involved, but this was just, if we don't count the review, this is actually a pretty quick question. If you know your stuff, just knock it out, and that's pretty good. So A, B was in here, and there's C. All right, there's number 3. So 2016 AP Micro. There it is. Thanks for watching, guys. We will see you next time.